Good day, learners. Welcome to our mathematics lesson for today. My name is Nagile Ndlovu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Welcome to our today's lesson. We are going to be focusing on trigonometry, particularly the application of the sine rule, the cosine rule, as well as the area rule. By the end of this lesson, you should be able to apply the sine and cosine rules to solve a triangle. That means to determine missing sides and angles in the given triangle. 2, you should also be able to use the area rule to determine the area of a non-right-angled triangle. 3, you should be able to determine sides and angles if the area is given. Then definition of trigonometry. You are already familiar with trigonometry. You know by now what is trigonometry. Definition of sine, cosine, and tangent in terms of the trig ratios. Then types of triangles, as in sides or as in angles. Remember, triangles can be named in either using sides or using angles. For example, we can say it's an obtuse angle triangle, it's an acute angle triangle, it's a right angle triangle, or it's an isosceles triangle, it's an equilateral triangle, it's a scalene triangle. So angles can be named in either angles or sides. Then derivation of the sine rule and the cosine rule, as well as the area rule. Then you also know Pythagoras theorem and areas of shapes in general. Right, you are saying by definition a triangle is a polygon with 3 vertices, 3 sides, and 3 interior angles. You'll remember a polygon is any shape that is made up of 3 or more sides and is closed. It's a closed shape made up of 3 or more sides. Right, a right angle triangle is a triangle which contains a 90-degree angle. Then a non-right angle triangle obviously is that triangle which does not have a 90-degree angle. Then a mathematical proof, sometimes we are asked to prove certain theorems or prove certain questions along the way. A mathematical proof is a logical way of demonstrating that a statement is true. It has to be a logical way, step-by-step analysis or presentation. A rule in mathematics is a set way to calculate or solve a problem. Right, the question is when to use which rule. We know we have the area rule under this, we have the sine rule and the cosine rule. At any given time, you need to choose the rule that best suits your question. When we talk about the area rule, we are saying when can we use the area rule? If no perpendicular height is given. That's when we use that area rule. Yes, the area rule will always work, but we reserve it for non-right angled triangles. When we have a 90-degree angle in that triangle, we obviously use half base times height. But otherwise, nothing stops us from using this particular rule. That half base times height was derived from the area rule. When the area is given, you can use the area rule when 2 sides and an included angle are given, just like in the cosine rule, when 2 sides and an included angle are given. Then the sine rule, when do we use it? If no right angle triangles are given. In other words, if right angle triangles are given, we think of or we resort to our trig ratios, that SOHCAHTOA word or acronym. When you know 2 sides and 1 angle are given, not the included angle, it mustn't be an included angle. When 2 angles and 1 side is given, right? Then the cosine rule, if no right angle is given, when 3 sides are given, in other words, when all 3 sides are given, you can apply the cosine rule to find some identified angle. when two sides and an included angle are given. So these are the situations that will enable us to use any of those three given rules. As you work through questions, you must always observe. First things first, these three always work in a non-right angled triangle. In other words, for those right angled triangles, there are some specific approaches that one can use. You can think of Pythagoras theorem. You can think of the trigonometrical ratios when there is a 90-degree angle. Right. In triangle ABC, remember triangles are named according to their vertices. So the capital letters always go to the vertices. In this case is A, B, and C. Then the side that is opposite every capital letter is a small letter. So the side BC, which is opposite big A, is called small a. Then the side AB, which is opposite big C, is called small c. And then the side opposite big B, which is our AC, is small b. So if I don't want to refer to my line BC as BC, I'll just say A. I look across, I see which angle is involved. Is angle A, vertex A. So the side that is opposite vertex A, I can simply call it A, small a, which is my BC, and so on. So according to the sine rule, the ratio A divided by sine A is equals to B divided by sine B, which is equals to C divided by sine C. And both these rules are examinable. You will be asked along the way or in any exam at any level from now onwards to prove the sine rule. You need to know how to prove the sine rule. You need to know how to prove the cosine rule. And they usually carry at least 5 marks to a maximum of 6 marks, depending on which one is asked for. Then the cosine rule stemming from that same triangle says a squared equals to b squared plus c squared minus twice the product of b and c multiplied by the cos of angle A. That's our cosine rule. This, of course, implies that our b squared equals to a squared plus c squared minus twice ac cos b. You must observe, when we start with small a, the angle is capital A. Then the other two sides are b and c. So when we start with c, these two sides are a and b, and the angle should be c. What leads is what ends in capital letters. That's the cosine rule. Then the area rule says, given this triangle, area of triangle ABC, I see the product AB and angle C. If you study careful, that product AB are sides BC and side AC. In between those arms, there is angle C. So it means it's an angle, two sides and an included angle. That's what we mean by two sides there, two sides and an included angle. It's our two sides and an included angle. It's this side here. Okay, it's moving. It's these two sides and that angle there. Right. So the formula is half AB sine C. It's half AB sine C. Okay. So it's this and that. These are our small sides, and then the included angle is that big C there. Okay. Right. Here is our first question for the day. Question number 1. It says, in triangle PQR, QR is 3 units, and then PR is x units, PQ is equals to 2x units, and we are given an angle which is at Q is angle theta. This is our angle theta. Then the first part of the question, you can take down the diagram if you want to, is PQR. Then the longest side there happens to be PQ, although we may not rely on the sketch. Remember, these are just but sketch diagrams. We may not know whether that 2x is greater than 3, but of course it is indeed greater than 2x. Right, so PQR, there are the given sides. Sometimes sides are given algebraical, 2x and x. The examiner decided not to tell us what is the value of x. Chances are high, therefore, that they may as well ask us to find x at some point. It will all depend on the question. Okay, right. The first part of the question says for 3 marks, all in all, this question carried 12 marks. Show that cos theta equals to x squared plus 3 divided by 4x for 3 marks. Then the second part of the question, 1.2, we are told now that if x is equals to 2.4, I don't know where they got that 2.4 from, but you will see later on why they chose 2.4. If x is 2.4 units, determine the value of theta, calculate theta. Then 1.2.2, calculate the area of triangle PQR. This is where you need your area rule. Then 1.3, calculate the values of x for which the triangle exists. What a question. Number 4, that's a level 4 type of a question, which requires you to think outside the box. But first things first, we need to show that cos theta is equal to x squared plus 3 divided by 4x. How would you proceed? And you can't say this time around cos theta is adjacent over hypotenuse. There is no 90 degrees here. Let's be very, very careful. Otherwise, you'll take it for granted and say cos theta, there is my adjacent QR, there is my hypotenuse 2x. That is not a hypotenuse side because we don't know the size of angle R. It's not mentioned. We haven't worked out and confirmed that R is 90 degrees if ever it's 90. All I see is a triangle with 3 sides given, although 2 sides are algebraically represented, and my angle theta. That's all I have. Never make assumptions in these types of questions. Sometimes the diagram itself is tempting for you to think that the angle at R is 90 degrees, yet in the actual fact it's not 90. So let's not use our eyes because they will deceive us. Let's use facts. So how would one proceed on this type of a question? How would you proceed on this type of a question? Yes, first things first, we need to use the cosine rule. We have 2 sides and an included angle. This is where you use your cosine rule. Right, I will start by labeling my sides. I said the side opposite a big letter is a small letter. So this is my small q, opposite big Q. This is my small r, and then this is my small p. Right, I can come up with a formula therefore and say the side that is having the angle is this one here, is small q. So I'm going to have a formula q squared equals to r squared plus p squared minus cos of twice, let's say twice first. Let's say twice minus twice minus twice the product of r and p cos of our angle at q. So if small q leads there, our last q, a letter must be a capital Q. We'll then replace for Q, R, P, and then big Q. Maybe we can rearrange this and say our 2 RP cos Q, I'm moving it to the left hand side, is equals to R squared plus P squared minus Q squared. I'm rearranging because at the end of the day, I want to solve for cos theta. Having done that, I'm now going to replace. Where there is R, I put 2x. Where there is P, I put 3, and so on. Let's replace. Proceed on your own and replace there. Replace the letters R, P, and then this is Q for now. I want you to replace R, P, and Q, and small q. The whole idea is to show that cos of theta is x squared plus 3 divided by 4x. Our answer is in terms of x. One may wonder, why did I start with q squared? I took advantage of the given angle theta, and the side that is opposite theta is q. That's why my formula took off with a q squared. Okay? Then let's substitute. You are saying is twice our x, our r is 2x, times our p is a 3. Then cos of theta, we replace q and put theta. This is equals to, on the other side, we square r, which is what? Our 2x squared added to 3 squared. It's always wise to put these in brackets. Then minus our q, small q is x squared. Then we simplify. This side, what are we getting? I'm getting 12x cos of theta is equals to 4x squared plus a 9 minus x squared. I'm already getting excited there. I see something happening. Then we proceed. We have 12x cos theta is equals to, there are like terms, 4x squared minus x squared. I get a 3x squared plus a 9. We want to solve for our cos theta. What are we going to do from there? We want to solve for cos theta. Yes, we are going to divide both sides by 12x. Let's eliminate this 12x. Divide both sides by 12x. This will divide and go. Therefore, our cos theta is equals to, right, if you proceed here, you are going to realize something. Look at the numerator. What do you notice in your numerator? What do you notice in the numerator? Don't think of factorization there in terms of quadratic equations, because that is a plus 9. Maybe what you can think of there is common factors. What is common there in the numerator? Focus on the numerator. Yes, our 3 is common. So we factor out 3. We are left with s squared plus a 3 divided by 12x. Then the 3 can divide into 12 to give us 4. So our final answer, therefore, will say cos of theta is equals to x squared plus 3 divided by 4x, which is what we're asked to prove. So you should have noticed here that I can apply the cosine rule. How do I know I can apply the cosine rule? The cosine rule can be used to find an angle when all 3 sides are given. In this question, all 3 sides are given. Once 3 sides are given, whatever angle you want to find, you can apply the cosine rule. In this case, the examiner wanted me to find the angle at Q. But unfortunately, I can't get the numerical value for for angle theta because of x. Hence, my final answer for now is just cos theta is equals to x squared plus 3. If I'm given x, then I'll be able to get the angle. I could have found r, I could have found p, but the examiner wanted the one named theta. Any question on this part? The question is, how would we know that we have to use the cosine rule? This takes us back to what we mentioned earlier on. The cosine rule is used when all 3 sides are given and you want to find one of the 3 angles or all of them. The cosine rule will always help you out. Secondly, you can use the cosine rule when 2 sides are given and an included angle. Then you want to find the 3rd side. It will also work. Okay, let's move on to the next question. The next question says, calculate the value of theta. Right. 1.2 was saying if x is 2.4, we are now told that x is equals to 2.4. We are given the value of x now. and we are asked to find the what? The size of theta, given that x is equals to 2, 4. How would you proceed? Remember, we ended here where we said cos theta is equals to x squared plus a 9 divided by 4x. That's where we ended. When actually it was plus 3 here when we were proving. It was a plus 3 there. Plus 3. Let me choose a red for you. Right, this is where we ended earlier on when we were asked to prove. Right, so next we are given, we just substitute. So our cos theta is equals to 2.4 squared plus a 3 divided by 4 multiplied by 2.4. Can you quickly simplify this for me and tell me what you get? We have just replaced our x with 2.4. Let's simplify and see what fraction we get overall. Punch that out on your calculator. 2.4 squared, then added to 3 and divide by 4 times 2.4 and simplify. I'm getting 73 divided by 80, which is less than 1. So it means we can evaluate and get the value of theta there. Therefore, our theta will then become arc cosine or inverse cosine of 73 divided by 8, which gives me, let's punch that on our calculators, arc cosine of, use fractions, 73 divided by 80, close bracket, I'm getting 24.15 correct to 2 decimal places, 0.15 degrees. That then becomes the size of this angle here, is 24.15 degrees. And then this side, we have already found it. You can just double 2.4, it goes to 4.8. We have already been given that x equals to 2.4. Then you double it. This one will become your 4.8 in short. Then you substitute and simplify. There was no need to restart the process because you already have cos theta is x squared plus 3. This is a continuation of the previous question. Then the next part of the question was saying, calculate the area of triangle PQR. Then the last part says, for which values of x will the triangle exist? Okay. Unless if there are some questions, let's move on to the area of our triangle. The area requires 2 sides and an included angle. We already have our included angle is 24.15 degrees. We've already found that angle. This part we said is the one that will double our 2.4. It goes to 4.8. Then this one is just our x, which is 2.4. So we have 2 sides and an included angle there. We can apply the area rule. So the 2 sides that are given is side R and side P and angle Q. So our formula, we then say we customize it based on the sketch, is half of R times P, then sine of, that's the area rule, it uses sine. Okay. RP sine of our angle Q, which is the angle trapped between those 2 sides. We'll then replace half of 4.8, which is our R, multiplied by, what's our P? Yes, it's a 3. Then sine of 24.15 24.15 degrees. Then you punch that on your calculator and simplify. You'll know your area. Let's punch it out and give me the answer. Half of 4.8 multiplied by 3, then times sine of 24.15 degrees. Yes, I'm getting 2.95 units squared, or square units. So your final answer there was 2.95 square units. The units were not given to us, so if units are not given, you say square units or units squared. Are there any questions before I proceed? Right, seemingly there are no questions. We move on to the most challenging part of this question, which carries 4 marks. Such a type of a question is normally referred to as a level 4 type of a question. You need to think outside the box now. Calculate the values of x for which the triangle will exist. Remember, QR is fixed. It's exactly 3 units. But these other 2, because of the variable x, they can be anything. So are we saying it can be just any number? I can put a 10 there. When x is 10, the other side becomes 20. I can put 100 there, and the other side goes to 200, because x is a variable. There is a reason why the examiner is saying, determine the values of x for which this triangle will exist. In other words, it will not always exist as long as you have x. It means there is a limit on x. It can't just be any x number. It can't just be any real number. Actually, not even real number. It can't just be any positive real number. It can't even be 0, for example. X can't be 0 in this diagram. Why can't x be 0? Yes, we know x is a variable standing for any number, but why can't it be 0 in this triangle? Any volunteer to respond to that? Why can't x be 0 in this triangle? I'm already seeing something here. I can't use x to be 0. Maybe I can try 1. Who knows, it might also fail. I can try 2. But there are some values of x that can't be used here. One obvious one is x equals to 0. It can't be used here. For what reason can't we use x equals to 0? Yes, it means the triangle will be destroyed. It won't be a triangle anymore. We are going to remain with only QR, which is 3 units. Because when you put x to be 0, it means you are nullifying side PR, because it's 0 units. Then on the other side is 2 times 0 is also 0. You are eliminating length PQ and length PR. Hence, the examiner is saying, for which values of x will this triangle exist? There is going to be some conditions here. For this thing to work, it means first things first, x must be greater than 0. That's one condition. X must be greater than 0. Right? And then we look at the angles here. Look at your angles. And remember, we also worked out cos theta as our x squared plus 3 divided by 4x. That cos theta must also be greater than 0. Cos theta must be greater than 0. In other words, we are observing a function above 0. Why above 0? Why above 0? Because this is a triangle. We are using positive values. And at the same time, our theta is going to be trapped between 0 and 90 degrees. Our theta must lie between 0 and 90 degrees. Having said this, we know the cosine graph always oscillates between -1 to 1. That's a standard cosine function. It must be between -1 and 1. Right. So it means if I have cos theta is equals to x squared plus 3 divided by 4x. What does it mean? It means this part here must lie between 0 is less than x squared plus 3 divided by 4x. That should be less than 1. Remember, the maximum value in the cosine graph is 1. The minimum is negative 1. But remember, here we are talking about x that has to be positive. We are talking about the angle that also has to be what? Positive, 0 and above. But we are not going to allow 0. That's why we are using a strict inequality symbol. We are not going to use a 0. Why? Because once we use a 0, it means our triangle does not exist. Or cos 0 will give us what? 1. Right. So we move on and solve for x. We have formed a double inequality. We have formed a double inequality. We want to solve for our x. Let me erase this. Right, having said that, I'm now going to say our cos theta gave us x squared plus 3 divided by 4x. This is where I'm concentrating. I want to solve for x. I will then say 0 is less than x squared plus 3 divided by 4x, and then that part must be less than 0. Right, I'm now going to focus on this part here. Otherwise, the bottom part will be invalid, 0 to that middle function. I will form an inequality, x squared plus 3 divided by 4x is less than 1. Then we cross multiply. We will get, this implies our x squared plus 3 is less than our 4x when we cross multiply. We'll then form a standard quadratic equation, which is x squared minus 4x plus a 3 is less than 0. This now takes us back to what? Yes, it takes us back to quadratic inequalities. We have to solve for x. We are going to factorize both sides. This side and less than 0. We are getting x and then x there. What are the factors of plus 3 that give us a negative 4? Let's factorize this quickly. Look for the factors of plus 3 that will build a negative 4. The middle term is negative 1 and negative 3. Then from there, we are going to find our CVs, critical values. Is when x equals to 1 and x equals to 3. These are our CVs. We'll then have to solve for our x. We'll know which values of x. Our CVs, if I may continue here, our CVs are equals to x equals to 1 and then x equals to 3. Then we normally solve them via this quadratic shape for our parabola. Since it's less than, we don't shade the ring there. We put our 1 here, we put our 3 there. Then which region is below the x-axis? This is our region that we are focusing on according to the question, because it said less than. So it means between 1 and 3, these will be our x values. So our final answer will then say 1 is less than x, which is less than 3. So it means we can't pick any other number except a number that is greater than 1 but less than 3. That's only when the triangle will exist. It will exist when x is a number greater than 1 but less than a 3. That's how we could have found the values of x that make this triangle to exist. You should have focused on the given value for the cos of theta, which is x squared plus 3 divided by 4x. That must be trapped between 0 and 1. y 0 and 1, we're not worried about the negative side. We're focusing between 0 and 1. The maximum it can reach is a 1. The minimum in this case is a 0. Why 0? Because x definitely has to be above 0. Right, that's one method that one could have used to answer this question. Let me move on to a second method. Let's move on to a second method that can also help us understand. I'm afraid of using this second method because it's a bit tricky. It needs someone who understands the sketching of triangles. But I hope you'll manage it. Okay. Here is my second method. Right. We are given a triangle here. We are told that this is a 3, this is a 2x, this is an x. What you must know from today onwards is that whenever you are given a triangle, you want to prove if that triangle can be drawn. There is a rule that we use. The rule states that the sum of the two shorter sides must always exceed the third side, which is the longest. But unfortunately here I don't know which one is the longest. So I'm going to form 3 inequalities. My first inequality will say 2x plus x must exceed 3. The sum of any two sides in a triangle must always exceed the third one. It's a rule. Then I will solve for x. 3x is greater than 3. I divide both sides by 3. I get x is greater than 1. In other words, 1 is less than x. Whatever value of x I'm choosing, it can't be anything except that more than 1. Then the other inequality that I can form is through saying x plus 3, I'm now taking the other two sides, must be greater than 2x. I then solve for x. This one will give me 3 is greater than 2x minus x, which means 3 is greater than x. What does this mean? I can as well stop there. I'm done. I don't have to go to the third one. It will be invalid. It will give me a negative value for x. In other words, if I say 2x plus 3 is greater than x, what does this mean? It means 2x minus x is greater than negative 3. Therefore, x is greater than negative 3. This is going to be not applicable. Why? Because x can't be a negative. It's a triangle. Distance can't be negative. So this automatically falls away. Then I'm left with only these two here, wherein I can rearrange and say 1 is less than x and that x is less than 3. That could have been your alternative approach to the question. All right, let's proceed. Let's move on to question number 2. This one is yours. I'm going to give you 1 minute or to a maximum of 2. Let me say 2 minutes. Go through this question, work it out on your own. Question 2.1. It says in the diagram below, angle P is 67 degrees. Then side PR is 9.2 centimeters. Side PQ is 3 centimeters. Calculate the length of QR. Quickly work out the length of QR. Start the diagram. Look at what is given, which rule is applicable. Obviously, area rule is out because we are not given area here. Think of the sine and the cosine rule. If it's a sine rule, when do I use the sine rule? If it's a cosine rule, when do I use the cosine rule? Which rule best fit our question? Let's proceed. You're looking for QR. Find QR. Just to guide some of us as we work through, opposite side is small p, yes. Opposite side is small q, opposite side is small r. Just to remind you. Yes, let's work, boys and girls, let's work. Must practice this skill. Don't just sit and wait for the answers. I know where you're going to get stuck along the way because of those decimals. But give it a try. Right, thank you. First step, you write down your formula. You want to find QR, which is p squared, equals to r squared plus q squared. It's always important to write down the formula. 2rp cos of big P, small p, big P at the end. We are applying the cosine rule. For what reason? Two sides are given and an included angle. You apply the cosine rule to find the third side. So we're looking for p squared. Let's maintain our p squared. We know our r is 3 squared, which will give us a 9. And then we know our q is 9.2 squared minus twice 3 multiplied by 9.2 cos of 67 degrees. Right, if you simplify here, you punch the whole of this on your calculator. You will get p squared is equals to 64. Sorry, it's 93. I'm getting a 93 there. Right, I'm getting a 93.64 minus, if I find the product of 2 times 3 times 9.2, I'm getting a 55.2 cos of 67 degrees. When you get here, don't try to punch that out. The whole idea is to find P. So take advantage and straight away say P equals to square root of, remember, it's a distance. I don't have to say plus or minus. 93.64 minus 55 times cos of 67 degrees. Especially when decimals are involved, cos of an angle is involved. Avoid early rounding off error. This is 52.2. Avoid early rounding off error. Because if you punch cos 67 multiply by 52.2, you'll be forced to round off that early. So rather keep it intact like this. Press the final answer on the square root sign. Then you'll know your length of QR. Therefore, our QR will then become, let's punch. Yes, I'm getting 8.49 after rounding off centimeters. That is the length of QR. You apply the cosine rule. Then we move on to the next question, 2.2. This one is very, very tricky. It looks simply a diagram, but it's tricky along the way for 13 marks. That 13 marks is part of that 2.1. Right, the question says in 2.2, in the diagram below, DCB equals to alpha, and then AC equals to H units, and angle ACB is equals to theta degrees. The first part of the question says, determine the size of angle ACD in terms of theta and alpha. How big is angle ACD? This angle here. How big is this angle here in terms of theta and alpha? Let's write down that answer in terms of theta and alpha. 2.2.1. We can answer that one for 1 mark. Determine the size of angle ACD in terms of alpha and theta. So our ACD angle is equals to, what you should realize in this diagram is that the whole of that angle C is theta degrees. Then we decide to cut out or slice out alpha degrees. What remains? If the whole of that angle theta was, let's say, 70 degrees, and the whole of angle alpha is 30 degrees, how big should be that angle ACD marked in red? How would you approach that question if numbers were given? Theta is 70 degrees, alpha is 30 degrees. How would you build angle ACD from those two? Yes, thank you. Is theta the bigger angle minus alpha the smaller angle? This will earn you 1 mark for that. Already you have a mark there. Then 2.2, prove that AD equals to H sine theta minus alpha. Right, what I would suggest you do in this type of a question is to fill in all the angles that you can fill in. Let's fill in all the angles that we can fill in. Look at your sketch and fill in all the angles that you can fill in there. For example, we already know this is theta minus alpha there. Which other angle can we fill in? Yes, angle D2. This one here is 90 degrees minus alpha. Any other? Sum of angles on a straight line, you can get D1. Alternatively, D1 is equals to, let's say D1 is equals to the sum of the opposite interior angles. It's an exterior angle. This is an exterior angle of triangle BCD. So it's going to be 90 degrees plus alpha. Another learner could have said, or D1 equals to sum of angles on a straight line is 180 degrees minus 90 degrees minus alpha, which is the angle at D2. Then you simplify, you get your 90 degrees plus alpha. It wouldn't affect you. So we know this angle here is 90 degrees plus alpha. Then there is only one missing angle now, which is angle A. What could be the fastest way of finding angle A? The fastest way of finding angle A. Yes, our angle A is going to be 90 degrees minus theta. It's 90 degrees minus theta, sum of angles in a triangle. Alternatively, use the whole of the big triangle. It's 90 degrees here, is theta there. Therefore, this one should surely be 90 degrees minus theta. So we have found all the interior angles. But the examiner is saying, show that AD equals to H sine theta minus alpha divided by cos alpha. How would we show that? We are going to go back to this diagram. We have already found this angle here. We are saying it's 90 degrees plus alpha. This one is theta minus alpha. Then this one here is 90 degrees minus theta. Right. We want to find the length of AD. Which rule is applicable? What is given? All three interior angles are known, and one side opposite one of those angles is known. Which rule is that? Which rule is that? Well done. It's the sine rule. So we're going to use the sine rule. We say H divided by sine of angle D1 is the same as AD divided by sine of theta minus alpha. This is our sine rule. We know one side that is given is H. and is across angle D1, which we have found to be 90 degrees plus alpha. Then from there, we want to solve for AD, which is our small c. Let's substitute for what we know. We know D1. Our D1 is h divided by sine of D1 is 90 degrees plus alpha, then equals to our AD divided by sine theta minus alpha. Then we cross multiply. As we cross multiply, we'll get h sine of theta minus alpha divided by sine. I don't know whether I should delay the process a bit or so long simplify. Right. Let's look at the denominator. This should be over sine of 90 degrees plus alpha equals to AD. We have found our AD. But the answer that we have and the answer that the examiner has are not the same. So we need to say, therefore, our AD equals to h sine of theta minus alpha divided by, we stop. When you look at your numerator, we don't have a sine 90 plus alpha. How can we convert sine 90 plus alpha to using cofunctions? In which quadrant is 90 degrees plus alpha? We need to reduce that using cofunctions. We're using cofunctions. Reduction via cofunctions. The moment I see 90 degrees plus theta, 90 degrees minus theta, I think of cofunctions. So this can be converted to cos of alpha. Yes, because we are in the second quadrant where sine is positive. Therefore, whoever comes to replace that must come in a positive sense. Therefore, it's cos alpha. We have thus proven that AD is h times sine of theta. This is what we are trying to prove here. AD is h times sine theta minus alpha divided by cos alpha. That's how you could have proven this. First things first, fill in all the angles that you can fill in. Fortunately here, we managed to get all the angles that are involved in the diagram. Then we now zoom in to triangle ADC. We take advantage of triangle ADC because we want to find the length of what? AD. Our answer involves our h. So in a way, we needed to find h. Okay. Or rather involve h. Then we move on to the most simpler question, which this time says, given that you have found your AD, determine the length of AD. Usually, these questions are very tricky. Here is a learner who fails to show this part. Don't feel intimidated and you end up skipping the question, because we can proceed from here and say, I know our AD from what is given is equals to h sine of theta minus alpha. Never allow yourself to get a 0, because there are some parts that can still be answered even if I fail to show this. It's a question of just substituting for h, theta, and alpha. Then I proceed and substitute and find my AD. AD is therefore, our h is given as 17 multiplied by sine of our theta is 58 degrees minus 23 degrees divided by, all this is divided by cos of alpha, which is 23 degrees. The rest is calculator work. The rest is calculator work. If you want to show a little more steps, this is sine of 58 minus that. What am I getting? Yes, 35 degrees divided by cos of 23 degrees. You should have collected these 2 marks, even if you struggled with the first part of the question. Punch out that and give us the answer. What answer are we getting there? Yes, I'm getting 10.59 units. That's the length of our AD, is 10.59 units. The next part of the question then says, calculate the area of triangle AEDC. AEDC, area of the triangle. We already know our H is 17 here. That's our H. We already know our AD is 10.59 units. We found that just now. Then we know the angle at A. We can get that angle at A is 90 minus theta, but theta is given as 58. So it's 90 degrees minus 58 degrees, which gives us what? 32 degrees. So it means you now have a triangle. Two sides are given and an angle between. Therefore, the area can be calculated. Our area will then become half multiplied by 17 multiplied by 10.59, then times sine of 32 degrees. That's how you could have obtained your last 3 marks. You needed to find angle A on your own. You can't use any other sides because you don't know the length of CD. It's unknown, length of CD. We don't know this length, so we can't use angle C. Neither can we use angle D1. We also can't use angle D1. So the only angle that we could have used is 90 minus theta degrees. Fortunately, we know theta is 58. We subtract and get 32. Then we punch on our calculator. We are getting 47.7 square units. That's how you could have found the area of that triangle. Are there any questions, boys and girls, so far before I proceed? Let's not wait for too long and ask only towards the end. It will be difficult to go back and look at what we have already covered. Any question? This is how we could have collected your 13 marks. That's how we could have collected your 13 marks. Right, let's proceed. Here is our next question. This one seems to be $1 million one. Very tricky. In the figure below, acute angle triangle ABC is drawn having C at the origin. What's the question? We are asked to then prove the cosine rule. Prove that C squared equals to A squared plus B squared minus twice AB cos C. Having done that, hence or otherwise, deduce that 1 plus cos C equals to the product of A plus B plus C and A plus B minus C divided by 2AB. 10 marks. What a question. Where would you start answering this question? This is a very, very tricky question. It looks short, 2 lines, 10 marks. Just 2 lines, 10 marks. 1 diagram, 2 lines, 10 marks. How would you prove that C squared? There is your C squared, small c here, small a there, small b there. How would you prove that C squared is equals to A squared plus B squared minus twice AB cos of big C for 6 marks? Okay. Right. We are going to use only 2 methods here. Of course, there is a third one. We are going to use 2 methods. Step number 1, when you get a question like this, you start by finding the coordinates. I'm going to use the method of coordinates. Right? This is my 90 degrees. I will keep this as my B. This is my small a. This is my small c there. I'll leave it there. But remember, the whole of this length here up to there is B. The whole of that length is B. And we are starting from the origin there. So if this B was a 10, it means it's 10 units from C to A. So it means I can find the coordinates of A here. The coordinates of A, I can write them as B and 0. I can also take advantage and find the length of, let's call this point D, the length of OD and the length of DB. I want the coordinates of B here. How would I find, using ratios, the length of OD, which is your X side there? This one is your Y side, which is the height. How would I find? So step number 1, you drop a perpendicular height from B to D. It will split up CA, but I'm not going to split it up in this method. This one will use coordinates. Right. What are we saying here? We want to find X on the diagram using this angle C here. This is angle C. So how can you find a small x using angle C? We can say cos of C is equal to adjacent over hypotenuse. My adjacent is X, my hypotenuse is A. In triangle, using triangle OBD. In triangle OBD, cos of C is X divided by A. A is the hypotenuse side, X is the adjacent side to C, angle C. Then we cross multiply, we solve for X, we get X equals to A cos of C. We have found our X. Then we want the Y is opposite over hypotenuse. So our sine of C equals the opposite side divided by the hypotenuse. Again is our A sine C. Therefore, Y becomes A sine C. We have found both X and Y, but it's in terms of trig ratios. I'm using triangle OBD to find the missing sides. Vertical distance from D to B, horizontal distance from O to D. I'm taking advantage of that right-angled triangle so that I get to know the coordinates of B. So X at B is A cos C and Y at B is A sine C. Those are the coordinates that I'm interested in. We have found those coordinates. So it means we now sit with two coordinates. Our coordinates of B is A cos of C and then A sine of C. And that is our line AB. How long is our line AB? Having found those coordinates, let's find the length of AB. Let's find the length of AB. Right. So our AB squared equals to, let's apply the distance formula. AB squared, which is your small c there. How do you apply that, given that you now know the coordinates of A is B0 here? You want to find the length of line AB using the distance formula. This method requires the distance formula. So our distance formula says AB squared is equal to x2 minus x1 squared plus y2 minus y1 squared. What is our x2? I will use A cos C squared is A cos C. Let me remove this part. Right, is A cos C minus, what is our x at A is B. Then we square this, plus we go to y is A sine C minus, that is y2, 0 there. Then we square. We proceed and simplify. Let's expand this. What are we getting? Let us expand. I'm getting here a squared. Then, let me shift it a bit lower here and say equals to, I need more space there. Right. I'm going to have a squared cos squared c, then minus the product of these two, which is 2ab cos c plus b squared. That's what you get when you expand the first part there. Then for the last part is a sine c minus 0, which is just a sine c squared, which is a squared sine squared c. That's what we have there when we expand. Then we group like terms and see what happens. Let's group like terms and see what happens. I have a squared here, cos squared c, plus a squared sine squared c, plus I have b squared minus 2ab cos of c, minus 2ab cos of c. Then you will realize here that a squared is common. You are left with cos squared c plus sine squared c, which is an identity, plus b squared minus 2ab cos of big C. Cos of big C. What do you realize there? Yes. Sine squared c plus cos squared c will give us a 1. So basically, that is a squared times 1. So in my next step, I will have a squared times 1, then plus b squared minus 2ab cos c. Therefore, we are going to have our ab squared from the previous is a squared plus b squared minus 2ab cos of c. But then don't forget your ab. Your ab is actually small c. So we replace, therefore, small c squared is a squared plus b squared minus 2ab cos of c. That's how you could have proven that using this approach. So first things first, you drop your perpendicular BD, then you solve for the horizontal distance and vertical distance in the new triangle OBD. Okay. Right, let's move on to the second method that one could have applied there. Let's move on to our second method. I want us to quickly touch the second method. Maybe some of us might love this second method. Right, second method, again, you start by dropping a perpendicular height. There, 90 there. This is your small c. This is your small a. Call that h. And then let this be x. But remember, the whole length was b, so this is b minus x on the other side. That can be your b minus x. It's a fairly easy approach also. You focus in triangle CBD. Let's call this point D. In triangle CBD, let's focus on CBD. What do you notice? Yes, A is the longest side. So A squared equals to x squared plus h squared using Pythagoras' theorem. Pythagoras' theorem. And you call this your equation 1. Done. There's nothing more that you can do there. A squared equals to h squared plus x squared using Pythagoras' theorem. Then in triangle BDA, BDA again is a right angle triangle. What do you notice? Our c squared equals to h squared plus b minus x squared. remember what I said, the whole of this length is b. So if we cut out x units, the other side will be b minus x. If you add x plus b minus x, it goes back to b. The whole length was a b, but we're cutting out x or subtracting x, which is cd. What remains is b minus x. Then I will proceed. C squared equals to h squared plus, let's square that part, we get b squared minus 2bx plus x squared. That's our c squared. We continue. Our c squared equals to h squared plus x squared. Allow me to collect h squared plus x squared for a reason. Then plus b squared minus 2bx, like that. Then you are going to realize the following here. Look at this. Look at this here. And look at that up there. Who is that? That's why I deliberately collected that x squared together with h squared, because I already saw something familiar earlier on. Okay? Right. What do we have there now? It means where I see x squared plus x squared, I can put a squared. Therefore, c squared is equals to a squared plus b squared minus 2bx. Done. But there is a problem. I still need to find that x there. I still need to find my x. Let me just pick this color for you. I still need to find that x there and replace it. Where is x? X is in the diagram here in triangle CBD. How can I solve for x there? I can solve for x by saying here sine, actually cosine. You can use cosine there. Okay, cos of c is equal to adjacent over hypotenuse. Then you solve for x. Therefore, x equals to a cos of c, like in the previous approach. That implies, therefore, our c squared equals to a squared plus b squared minus 2b. Stop, replace x and put a cos of big C. There goes your formula again. So you could also have used these two triangles, separate them, but must see the links. These x squared plus h squared will always give you a squared in this case. Where I see x squared plus h squared, I replace and put a squared coming from the two diagrams, working with the two diagrams at the same time. Okay. Then the next question said, show, there is our next question. We need to show this part here, that 1 plus cos x equals to a squared plus that, all divided by 2. How do we show that? Let's start from, we have already just proven that c squared equals to a squared plus b squared minus 2ab cos of c. Right, from what I saw, we need to show that 1 plus cos c is equals to the statement that was given there. So how do we proceed from here? Let's rearrange and have 2ab cos of c. Let's transpose negative 2ab equals to a squared plus b squared minus c squared. Okay? We can see these numbers are squared. It looks like a difference of 2 squares, but it's not really a difference of 2 squares. Allow me to pause there for a moment and look at this. 2 squared plus 3 squared. I want to combine those. If I combine these, I'm going to say 2 plus 3 squared. You will see what will happen. 2 plus 3 is 5. 5 squared is a 25. which is no longer 13. You'll realize that when you expand here, there is the product of 2 and 3 coming. So we must say minus twice 2 by 3. 2 by 3. Remember, when you expand this thing, there is a product, that middle term, coming into play now. We'll have 2 squared plus 3 squared, then minus the product of those two doubled. So this is the same as saying 2 plus 3 squared minus 12. There is a 12 that will come into play that we don't need. That's why our answer goes to 25, which is your 5 squared. This then goes to 5 squared minus 12, which is 13. Same as squaring this to get 4 plus 9. So I want to combine these two and make them 1. So how do I do that? Using the same idea. How can I use the same idea? Right. I'm going to say 2ab cos of c equals to a plus b combined squared minus 2ab then minus c, which is the same as a plus b squared. I have to remove c squared, then minus 2ab. What do you notice? This is now a difference of 2 squares. Therefore, 2ab cos of c is equals to difference of 2 squares is going to be a plus b minus c. Let's say plus c multiplied by a plus b minus c, then minus 2ab. I'm treating this as one thing. It's a difference of 2 squares. Then I'm going to divide throughout by 2ab, even this part by 2ab. This will divide and go. Then this will give me a negative 1. We then move the negative 1 across. It will give us what we're asked to prove here, that the final answer is going to be, remember, we now have cos of c is equals to a plus b plus c times a plus b minus c, difference of 2 squares, minus 1. Then we move the 1 across. 1 plus cos of c equals to what we are given. This is over 2ab after dividing. A plus b plus c multiplied by a plus b minus c. All this is divided by 2ab. So the skill here was to notice the following, that in maths, if you are having some terms that are squared, you want to combine them, there is always minus the product of those two doubled. Okay. Then we're moving on to the last question for the day. This question says quadrilateral ABC is drawn with BC 235 meters and AB 90.52 meters. It is also given that ADB is 31.23 and then DAB is equals to 109.16 degrees and CBD is equals to 48.88 degrees. Right, this one is going to be your homework. I want you to take down this question because we have done a similar question in the first few minutes of our lesson for today. I want you to take down this question. Then take down the sketch, take down the story. We'll just summarize and see what we have so that you can go and do it on your own. Yes, having taken down the question, it says determine the length of BD for 3 marks. Determine the length of CD for another 3 marks. You need to think of the sine rule, think of the cosine rule. That is a quadrilateral that has been cut into two triangles for some reasons. And you can see already on the diagram what is given, which A side can I find given the little information that I'm having, where can I start. But the first part of the question wants you to find BD, which is your small a there. How do you get that small a? Are you going to use the sine rule? Are you going to use the cosine rule? Depending on what we know about the use of those rules. Obviously, having found your a, it can help you to get CD here, which is small b. So you're basically looking for small b and small a. But you can't start by finding small b because you don't know small a for you to jump into triangle DBC. So your challenge is go and find a, then use that a to find b. That's the hint that I'm going to give you. Make it your homework. Before you sleep tonight, make sure that question is done. Otherwise, I'm going to stop here for today. If there are some questions, I can entertain one or two. Otherwise, our lesson is going to end here. Are there any questions? The only thing that I can emphasize, maybe some of you did not pick it up, is only this part here. Just to wind up, it's only this part here. It's a skill that you must have on these types of questions. I know some of you got stuck there, although you don't want to ask that question. Is when we say, if I'm given 3 squared plus 4 squared, how can I combine these two and make them share the same squared? It comes with some consequences. If I just combine like this, because of plus, it's not a multiplication. If it was multiplication, it was going to be straightforward. Then I just say squared like that. Already my answer is wrong. My answer is wrong. Because this is now 7 squared, which is 49. Yet the answer here is a 25. 3 squared is 9, 4 squared is 16. 16 plus 9 is 25. They are no longer equal. This side is now 9 plus 16. It will never be equal to 7 squared. So meaning something needs to be done to this 7 squared, which is 49. Yet the answer should have been 25 is not equal to 49. What must I do to 49 to come back to 25? I must subtract a 24. So here it means if I want them to balance, you say minus double the product of what you see. After putting them together, you double the product of what you see. Double the product of what you see. Sorry, let me quickly go back there. Double the product of what you see. That's how you can combine them. Double the product of what you see. So it's going to be 3 plus 4 squared is this minus double 3 times 4. It will work. This means you now have your 7 squared minus 24, that product. So if it's letters a squared plus b squared, you want to combine them. You say a plus b squared minus double the product of those two. Then from there, that's where we had a squared plus b squared minus c squared. We treated this as, okay, by the way, this is now in brackets. This is now in brackets like this. A plus B squared is like one thing, which is could be, let that be K or Y. You will realize that this is now a difference of two squares, which simplifies to A plus B plus C times A plus B minus C. Then minus that 2AB. That's where we got that one from after dividing throughout by 2AB. That's where we are getting A plus B plus C in that question. Otherwise, we are going to stop here for today, boys and girls. In our lesson, we focused on the following. 1, applying the sine and cosine rules to solve a triangle, that is, find missing sides and angles in the given triangle. 2, we use the area rule to find the area of a non-right angle triangle. And along the way, we used the sine rule, which states that sine A divided by A is equal to sine B divided by B, which is equal to sine C divided by C. Those can also be written starting with small letters. The sine rule is used when the following conditions apply in a non-right angle triangle: when two sides and an when two sides and an angle opposite one of the two sides is given, when two angles and a side opposite one of the angles is given. You can also take a pic of these notes. Then in conclusion, again, for any non-right angle triangle, our A squared, that is now the cosine rule, can be written in 3 different ways, but just mastering one is sufficient. A squared equals to B squared plus C squared minus twice BC cos A, and then B squared is A squared plus C squared minus twice AC cos B. Whatever letter starts, the capital letter will end. And C squared equals to A squared plus B squared minus 2AB. This is a squared. And then the cosine rule is used when the following conditions apply in a non-right angle triangle. All 3 sides of the triangle are given, and you want to find a missing angle. Or 2 sides and an included angle are given, and you want to find a missing side. The area rule is then used again in a non-right angle triangle where 2 sides and an included angle are given, and is given by the formula: area of triangle ABC is half AB sine C, or half AC sine B. You see, the small letters are A and B, but the angle is C, which means it's that angle trapped between sides A and side B. Okay. Otherwise, thank you for attending. We'll meet again. Until then, work hard, study very hard, try to internalize the concepts. Thank you.